Hello, and welcome back to the Mastermind channel, Algebra 1, Chapter 7.5, Adding and Subtracting Polynomials. Poly comes from many, multiple polynomials. Alright, so that means we don't just have one nomial, monomials, we have polynomials. 1, 2, 3 terms. We're adding 3 terms to 3 terms. So the first thing to note here is that these parentheses are not being multiplied by anything, or it doesn't look like it, which means there's a 1 in front of them. So that's 1 times these parentheses. So 1 times everything inside there is just everything inside there. That means I can write that without the parentheses if I'm just adding them. And now I'm going to look to see which terms go together. And the important part here is that they have the same variable with the same exponent. Okay, so 2x squared and negative 4x squared go together. And then positive 5x and positive 6x. It's very important that you include the signs. The way I like to do this is, for my squares, I'll put a square type thing around it. Now, very important that you include the sign with it, that's negative. Okay, the variables without, I'll just put a circle around. And then I'll underline these two. That's how I know those go together. So I always start with the greatest exponent. Okay, in this case squared. So 2x squared minus 4x leaves me with negative 2x squared. Positive 5x plus 6x leaves me with positive 11x. And then finally, I have the constants. Negative 7 plus 3 is negative 4. And that is my final simplified answer. I can't combine any further because these are unlike terms. All right. Parentheses here. Again, it's positive. We're adding. So I can drop off the parentheses because that's like there's a 1 outside of them. And then combine like terms. So I'm looking to see which ones go together. Here I've color-coded them for you so you can see. Notice the square doesn't have anything in common. I'm going to start with the greatest exponent, so that's going to be my y to the third. Alright, so I'm going to combine this right here with this one right here. So positive y to the third plus 2y to the third. Remember, there's a 1 in front of it if you don't have a coefficient. So that makes it 3y to the third. Then positive 4y squared plus nothing else. That's alone. Alright, so then plus 4y squared. My next smaller exponent is just the variable by itself. 3y minus 4y is negative 1y. Or just minus y, and then my constants, negative 5 plus 8 is plus 3, and that's my final answer. Now, if I'm subtracting polynomials, it's almost as easy. There's just one thing to pay attention to. Remember, there's no number in front of the parentheses. There's technically a 1 there, which means now I have to multiply this negative 1 with everything inside the parentheses. Okay? So my first set of parentheses just had a positive 1 in front, so it's going to stay the way it is. But here I have to multiply negative 1 with 4x, negative 1 with negative 5, negative 1 with positive 3x, which essentially means I'm just going to go through and change all the signs. Okay, so then this is going to be negative 4x, this is going to be positive 5, and this is going to be negative 3x squared. Now I can go through and see which ones go together. Alright, so I start with my greatest exponent again. I'll start with 2x squared, and I'm going to include the sign. So that gives me negative 1x squared, or just negative x squared. Then here, I said I'd do squares. I'll do squares. There you go. Square around this. Circles around these. Okay, that's negative 6x, and then finally my constants, 3 plus 5 is 8. And there's my final trinomial as my answer. Alright, remember subtracting right here means I change all the signs inside the parentheses to negative because I'm technically multiplying everything by negative 1. So the positive 3p squared becomes negative 3p squared. Positive 2, negative 2. Negative 9p, positive 9p. Okay, so now I can combine all my like terms. I look for like terms. I notice, okay, there's my 4p to the third power and no like terms. So I leave that, 4p to the third power, then 3p squared, negative 3p squared, no like terms, so leave that as it is. And then 7p and positive 9p, add those up, we get 16p. And then finally, negative 8 and negative 2 gives me negative 10. Notice my exponents never change when I'm adding. So if I add p and p, that doesn't become p squared. If this was p squared plus p squared, it would still be p squared. It's not p to the fourth. Okay, that the exponent only changes when you're multiplying. Alright, word problem. Adding and subtracting polynomials. An electronics store is starting to track sales of cell phones and digital cameras. The equations below represent the number of cell phones P and the number of digital cameras C sold in M months. Okay, so phones, P stands for phones, C stands for cameras, M stands for months. Alright, first question is write an equation for the monthly sales T of phones and cameras. Okay, so T, the total sales, is phones plus cameras. So I have the phones, which is 7m plus 137, and then the cameras, 4m plus 78. And I can combine like terms here, 7m plus 4m, and the 137 and 78 gives me 11m plus 215. Now I can use this. It says use the equation to predict the number of cell phones and digital cameras sold in 10 months. Remember, M stands for months, so I'm going to put a 10 in there. 11 times 10 plus 215 is 325 phones and cameras. And that's all the fun we're going to have today. I will see you another day.